All right, well, welcome everyone to another exciting Learning Lab. This is Learning Lab 59, and what this one's focused on is customer lifetime value, and we're going to be doing something special today. This is our first full Python lab, and for those of you guys who have been following me at Business Science, I'm the founder and CEO. My name's Matt. And if you're coming new to business science, welcome, because this is really exciting. I know we're getting a lot of new people joining because of the new Python track that we just started offering at Business Science. And in our Learning Labs program, which is what you're seeing right now, we're now offering full-on Python labs. So 2 weeks ago, we did customer lifetime value with R and tidy models. This week, what we're doing is the same similar type of problem, but we're analyzing it with Python and Scikit-Learn, and we're going to be providing a nice Dash app, which I'll showcase here in a minute. This is going to go to our LL Pro members, and I'll be showing that off here in a second. So with that, we'll get started here. Our workflow for today. So if you've never attended a business science learning lab before, it's fairly heavy with code. So we have about 10, 15 minutes of dialogue up front where we'll go through the business problem. We'll talk about the challenges, the technologies that we're going to be implementing, and then we'll jump into some code in about 15 to 20 minutes. Our workflow, once we jump into that code, this is what we're going to be doing. We're going to be doing a lot of data understanding, and we're going to be building what are called RFM features. That stands for Recency, Frequency, and Monetary. So I'll talk more about that in the business case, but we're going to be using a lot of Pandas to analyze, and we're going to be making some plots. Then what we're going to do is we're going to jump into machine learning. And that's where this tool called Scikit-Learn is going to become extremely useful. We're going to create 2 XGBoost models. We're going to create one for predicting probabilities, and that's technically a classification problem. And then we're going to be creating one for predicting the next spend in 90 days that customers will spend. And that is called a regression problem. So once we get our machine learning done, we'll make some predictions, and then we'll funnel those predictions into an application that the business users can use. And that's what we're going to be showcasing today here. That's the LL Pro bonus. So if you join LL Pro, I'll talk about this in a minute, you're going to get this app as a bonus. Okay, so that's the high-level workflow that we're going to be going through, 1,000-foot view today. So let's get this thing kicked off. For those of you that have never seen a Learning Lab before, or for those of you that are interested in joining Learning Labs Pro, we offer these bi-weekly. I'm going to put the links into the chat right now if you want to check those out. I just put the Learning Lab Pro link in there. Check it out. What these labs are is just all sorts of topics that are outside of the core business science R track and Python track curriculums. So beyond the foundational tools, my students have requested specific examples of business problems and technologies that they want to see implemented. And that's where Learning Labs Pro comes into play. So every 2 weeks, what we do is a new lab. They're generally 1 hour. It's a project that we'll go through. This week, it's on customer lifetime value. In a couple of weeks, we'll be doing marketing mixed media modeling. And we're going to be doing lots more. We're going to be toggling back and forth between R and Python. So you can see here, we've got R, we've got Python, and we've got a lot of different technologies. So we're going to be going through these. We already have, this is the 59th lab. So there's 58 of these already in Learning Labs Pro. This one will get added here in tomorrow, and it will join as the 59th lab. What's really cool is in these labs, I give away a lot of bonuses. So this is just a sampling of some of the bonuses that I've been giving out the past couple of weeks. And these go to my LL Pro members. So when you join, you not only get the code and the videos, but you get all of these special perks. And generally, you can see I have a theme going on. I've been giving away a lot of shiny apps. So if you're familiar with R, there's a application framework called Shiny, and you can build apps with data science. So they integrate things like tidy models, stacks for ensembles, Torch in R, Light GBM in R, text recipes for NLP, the embed library for analyzing customer segmentations. And so we're giving away a lot of applications that integrate these technologies. Now, this is different though. This week, we're giving away a Dash app, and that's made by Plotly, or I built it with the Dash framework. It's a web framework, very similar to what Shiny is in R, Dash does in Python, it allows me to build this application, and it integrates tools like Scikit-Learn. And what this does is it allows us to analyze our customers and provide our business a solution that, or a data product that allows them to make data-driven decision-making. So let's check this application out. We'll just do a quick demo. This is the application. This is the end product that we're trying to create in this lab today. And what we're doing is we're building a customer analytics dashboard that predicts the spend that a customer will make, any given customer will make in the next 90 days. So these dots are all customers. And when I hover over them, you can see that this is customer 2,941. They have frequency of 25 purchases. Their prediction probability in the next 90 days is 88.6%. The spend total that they've spent with our company so far is $86. The predicted spend in the next 90 days is $71. And their actual spend in the next 90 days versus the prediction was a difference of $15. So they spent $15 more than what they were predicted to. So that's how you would read this. And what's cool with this app is this has all of our customers, and we have an algorithm running behind the scenes that predicts what they should be spending, and it compares it to what they've spent. So what I can do is I can funnel down, and when we start to funnel down, we can see that a lot of these customers, as I lower this, their actual spend minus the predicted spend. So when this number becomes very negative, those are the customers that were predicted to spend more than what they've spent. So you can see that this customer, 1,079, is a super high probability of purchasing, 96%. They're predicted to spend $153, and they've actually spent $100 for a delta of negative $53. So this might be a customer that we want to target with an email or something to kind of kickstart them to get them spending more money with us because they haven't spent as much as they were predicted to spend. So this is how you can use this tool. And then what's cool is you can just click this button called Download Segmentation, and it downloads a CSV file of all of these customers that have negative probabilities or negative actual predictions versus their predicted values. And what we can do is we can show it in the Finder, which opens over here, open that up. And right there, you have all of the kind of people that should be spending more money than what they have spent. And you have all of their customer IDs. And you can kind of scroll down through and see who was predicted to spend what and how much they spent. So that's how the tool works. It's a customer segmentation tool, and it's really useful for businesses who want to be able to target people that aren't spending as much as they were predicted to be spending. And that's what we're going to be doing today. That's our business problem. Okay. So let's talk about the business problem at a high level. We're analyzing what are called non-contractual business relationships. This is what happens where your company offers products that people can just come whenever and they buy. So the case study that we're working with is what we worked with 2 weeks ago. It's this company called CDNOW. They were a big company during the dot-com bubble. They're a company that actually went bust in the early 2000s, along with many other dot-com companies. And but what's cool is that CDNOW has a data set that they had released back in the early 2000s. And this was the subject of a lot of analysis, specifically because this is one of the first data sets where an actual company provided their anonymized data on their customers. And we got to see, kind of how those customers purchased and actual buying patterns. So it's a really useful data set. We're going to be working with it today. About that data set, it contains the history of 66,000 transactions for 25,000 customers. It was the launch of 19 new products. So these products are CDs that didn't have previous demand. And it covers new customers that never made a purchase before, that made their first purchase within a 3-month window of each other. So we'll talk more about that later. It's called a cohort or cohort analysis. And this was a really useful data set for this type of analysis. Our goals today, what we want to do is we want to understand which customers to focus on. At the end of the day, that's exactly what we want to do. I do this a lot at Business Science. I'm analyzing customers a lot to understand which customers are likely to purchase, running analytics algorithms on them. We have our own internal email targeting strategies and that sort of thing. So these techniques that you're going to be learning today are exactly what I actually utilize inside of my own business. So we're going to be focusing on a prediction task. We want to know two different things. We want to know how much will they spend in the future. So we're going to be analyzing that in terms of a value, and we can consider this not technically a customer lifetime value, but it's a customer next 90 days value. So we want to know how much will they spend with us in the next 90 days, and two, what is the probability that they will make another purchase with us? And these are different goals and slightly different strategies and slightly different techniques that we're going to have to implement in order to answer these questions. So there's three questions that I really want to focus on today. And these are the three most important pieces that you'll take away today. It's questions that actually we can answer for the business to be able to help them gain value from this analysis. So these are the three questions we're going to answer today. First question. Question number one is, which customers have the highest spend probability in the next 90 days? So we're going to be utilizing our predictions. We're going to create this table here, and each of these has a customer ID, and we can sort it. And you can see I'm using sort values here by this column, predict probability. And this has the highest probability of purchase in the next 90 days. So we're going to be able to answer that question right off the bat for our business. The next question, question number two, which customers have recently purchased but are unlikely to buy? So this is a different type of question, because what we're now doing is we're saying, okay, they've recently purchased. So we're going to take that data set these predictions that we make, and we're going to filter them to what are the most recent purchases. So we're going to be looking at any people who have bought something within the past 90 days, so relatively recently. And then we're going to see also which of those have less than a 20% probability of repurchase. We're going to sort those values. And then what this is useful for is it's being able to get in front of people before they, it's called dying in survival analysis. Before that customer dies, we want to revive them. We want to keep them as long as possible. So you can analyze this and focus on that segment of the customer base and be able to revive or revitalize some of these dying customers. So you want to do that, and this is the second question that we're going to answer today. The third question: which customers are predicted to purchase but didn't? So this is a different type of question. So these are people who had a high probability of purchasing, and we can analyze that by taking our predictions that we're going to make. And we're going to say, okay, we're going to predict that the spend 90 total, or we're going to filter into those who spent $0 in the next 90 days. And then what we're going to do is sort by their predicted spend values. And we see this person was predicted to spend $153, but they spent $0. So this is the perfect type of opportunity. And this is something that's really valuable to the business. These are missed opportunities. These are customers that are coming to our company, and they're not making purchases, and they're kind of hanging around, but they're showing that they should be making purchases. In fact, they've got a high probability here of 71%, and they were predicted to spend $153. So we got to understand why they're not spending, and we got to get in front of them. We got to get our marketing team to send them targeted emails in order to get them spending more money, because that's a missed opportunity, and that can generate a lot of revenue for your company. Okay. So let's talk about customer lifetime value modeling. So there's a couple of different approaches, and there's all sorts of different equations if you research customer lifetime value that are out there. Companies use this as a metric to gauge the profitability. So they want to understand which customers they should be focusing on. And generally speaking, what they try and do is they use different algorithms to calculate, what is the anticipated value of this customer given their previous buying history. So in short, the customer lifetime value is the profit that's estimated from the future relationship with a customer. You basically determine kind of like a profile for how this customer is likely to spend. and also the cost of retaining that customer. So you factor out and subtract out those costs, and that's what your customer lifetime value is. So there's many different approaches. They range from some more complex strategies to, and here's kind of like an econometric approach. And I will preface this, we're not going to implement the econometric approach here. We're going to be doing more of a predictive and machine learning approach. So one way is to calculate and use it as or model it as a discounted cash flow. So you have the contribution that customer is going to make, and then you subtract out their costs, and you have and there's also, because time is involved, you have a discount rate involved as well. So this is kind of like the econometric or cash flow approach to measuring customer lifetime value. I don't actually use this in my company because there are challenges. I've tried to use it personally, and it doesn't really give me that great of results. The machine learning, this is a scenario where I think machine learning does a better job. So the challenges with the econometric approach, I want to know specifically for my business which customers will contribute within a defined period of time. So lifetime is great, but what I'm normally interested in is the next 90-day period. So I want to know quarter by quarter which customers are going to be spending money with us. I personally have not found it accurate to implement the econometric approach. I've tried before, and I've quickly given up on it. Rather, what I do is I frame it as a machine learning approach, and this is what I've successfully implemented, and this is what I'm going to teach you today. So I'm going to show you how specifically to do some of the things that I do at Business Science. This is great. Let's talk more about this machine learning approach to customer lifetime value or customer modeling. So I use machine learning, and there's a couple different steps that I'm going to go through at a high level before we jump into the code. The first one is you want to normally subset a cohort, and why you do that is you want to take just a sampling of your customers that are within a defined period. They've all purchased around the same time period. They've experienced a lot of the same marketing. So there should be kind of relatively similar behavioral patterns going on with them, and also relatively similar events happening that they're all experiencing at the same time. So a cohort is just nothing more than a group of customers that all started around the same time. What we're going to be looking at is between January 1997 and customers between March that made their first purchase with our company, or CDNOW, between January and March of 1997. So this green box here, that's when they made their first purchase. And you can see that what this is this dark blue line, and then you've got a light blue line. The dark blue line is what is their aggregated buying behavior. So we've added all of the purchases they made up by month. And you see this type of pattern where after that they've made that first purchase, what tends to happen is it kind of dies down over time. And this is kind of a normal curve that you'll see with, because, not all of your customers that make your first purchase are going to continue buying at that same rate. And generally what happens is it kind of tapers down. This blue line is just the trend. So that's all that is. The second step is we're going to convert this to a machine learning problem, but we're going to implement what's called temporal splitting. That means we're going to split up by time. So we're going to take their purchasing behavior for a set period of time, and then we're going to analyze the last 90 days, which is that we have in our data set of their buying pattern. So this red piece, we're going to come up with, we're going to use to come up with our targets. And this blue piece, we're going to use to come up with the features that make the data set. So because this is a time series, we're going to say, okay, we're going to look at and calculate, we're going to sum up for each customer how much they've spent. And we're going to sum up whether or not they've spent anything in this time window. And that's what goes in this 90-day flag. And that's what goes in this 90-day total. And then the blue part, we're going to create what are called RFM features. So recency, frequency, and monetary features. And this is just kind of feature engineering. And we're going to take those from the blue period of their purchasing behaviors. Okay. So the RFM features are particularly important because these are really valuable features when you have customers that purchase over time, meaning they spend money at different timestamps, and you can use that spending behavior to come up with these features. So one is for recency. We're going to come up with some of those. One is for frequency. That's how many times they purchased. And then these two here are monetary features. What is their total purchases that they've made during that time period? And what is the average value of their purchase? And you can come up with many more features. In fact, this is called feature engineering. It's one of the art of the data science. Becoming a data scientist, good data scientists know how to come up with really good features. So this is what we're going to be implementing. And then we're going to create 2 predictive models. So once we have our data set formulated the right way, we're going to come up with model 1, which predicts how much a customer will spend. That's a regression problem. And then what probability a customer will purchase in the next N days, which is a classification problem. Okay. Again, this is the workflow that we're going to go through. We're going to go from Pandas to Scikit-Learn to Dash and Plotly. All right, so let's get started. Okay. This is the first lab that we're going to be doing out of VSCode. So I'm just going to quickly go through. I'm up here. These are my files, my file explorer here. I have that opened up, and this is the lab that I have all of the contents for. So it's got a couple of different folders, and for my LL Pro members, we'll just talk about this project setup real quick. I am going to be working out of this Lab 59 customer lifetime value. There's a couple of different folders. One is my VSCode settings. So these are some of my settings that I have for the specific workspace. We are going to be using the Jupyter Notebook integration, and we're going to be, when I hit Shift and Enter, we're going to be sending code to the console or to the interactive window. So I have this setting here. And then also the Python path I have set up to my Lab 59 customer lifetime pi, which is just an environment that I've created. And I'll talk more about that here in a second. So the environment is important because that has the specific versions of the Python packages and libraries that we're going to be using today, and make sure that you have the right ones working. The next one is the artifacts. So as we go down through our analysis, we're going to actually be creating these. So I'm not going to spend too much time on them. This is just basically think of it like saving our work at the end of our analysis. The next one is the data set. So the data set, it's saved in a text file. So if I click this right here, the text file looks something like this, where we've got customer numbers, we've got their date, and then we've got the number of purchases, the number of CDs they purchased on a specific order for a timestamp, and the value of their order. So this is what the data set looks like that we're going to be working with, and that's stored in the data folder. These 3 are related to the app, and I'm actually going to, I'll open them briefly, but we'll spend more time on these at the end. The app commands. So if you've never made a Dash app before, what you'll do is you'll actually open up a terminal. And I have a terminal running right now, which is allowing my Dash app to be served. And what you'll do, so I'm going to close down by hitting Control-C. So my app is closed. What you want to do is you want to check out your Conda info. So if we do Conda info -ms, you want to make sure that you have the correct environment set up. So that's this Lab 59 customer lifetime pi. So that's what this next command does. When you do Conda activate, that'll activate, and you'll see in parentheses here the environment that I'm using. And then you'll just do Python app.py, Shift Enter. And what this is going to do is that'll deploy your app. So you'll just go to your local host 8050. And if I do localhost 8050, you'll have the app that'll get pulled up. Okay. So that's how you do the Dash app. Again, we'll show you more about that here at the end. There's an app.plot.py, which is just kind of a temp file as I was creating the Plotly plot for my app. This is the LL Pro bonus, the app.py file. This is what all my LL Pro members are going to get. So that app that I just fired up, this is the file. The environment.yml. So this is, if you're not familiar with Conda, this is how you will set up your Conda environment. So I'm using Lab 59 customer lifetime pi. In order to set this up, you run conda m create-f environment.yml. You run that from a terminal that is inside of this project. And what that'll do is it'll set up this conda environment for you with all the correct package versions. So you want to make sure you have to make this reproducible. You'll want to use the same environment that I'm using. So that's what we'll get set up there. And then if you need to make any changes to the environment, you can make changes in here and then just run conda env update. So the only thing that changes is it goes from create to update. If you want to make any modifications, you just run the second command here. Okay. And then the last file, and this is the one that we're going to be working out of today, is the Lab 59 customer LTV. So think of this as the analysis that we come through in order to create this app.py file. So to get started here, we're going to be working down through this file. It's about 300 lines of code or so. So it'll take probably about 25 minutes, 30 minutes to get through. The environment that I'm using is Lab 59 customer LTV Pi. You want to see that down here. If you don't have that, you can go to your settings, command palette, and then open up your interpreter. So if you do Python, select interpreter, and then just make sure that you've got your the Lab 59 customer lifetime.py. And then what will happen is that'll show up down here. Okay. So other than that, that's pretty much how to get set up. We're going to load some libraries. The libraries that and I'm going to hit shift and enter, and this is going to go to an interactive Jupyter window. You can see what's running right now. I've got, and this looks a lot like Jupyter. And also you can see over here, the interpreter is Lab 59 customer lifetime Pi. That's shows you that it's working. So we just imported Pandas and NumPy. These are kind of like your basic, core data science and data wrangling libraries. We're going to import joblib. I'll show you what that's going to be used for here a little bit. There's PlyData cat tools for working with categorical data. And then plot9 for doing some static plotting. And then the main machine learning libraries that we're going to be using, XGBoost. We're importing the XGB classifier and XGB regressor. And then we're going to use Scikit-Learn's grid search CV on both of these to create our machine learning models. Okay. One more thing, I'm going to set the PN. So this is for my plot9, my options DPI equals 300. And that'll make our plots look a little bit more crisp. All right, so now we're going to move into the data preparation section. So the first thing I'm doing here is I'm just reading in that data from our CDNOW master.txt file. That text file is a little weird though. It's separated by spaces, but they're uneven spaces. So I have to use a separator of /s+. And what this does is it looks for one or more spaces between each line. So if I just check out this file right here, I can see that if I scroll the whole way to the top, the first line, this one has 3 dots, 3 spaces. This one has 2 spaces, and this one has 1 space. So it goes 1, 2, and 3. In order to pull that in the right way, we're going to use read CSV, but the separator, instead of a comma, it's going to be a /s+. And then I'm just going to give it some names, customer ID, date, quantity, and price. And that's going to be the names for each of these. This is the customer ID. This will be the date, quantity, and the price. Okay, so I'm going to pull that in now. We'll take a quick look at it. So shift enter. Here, hold on one second. Need to do shift enter to pull it in. Should be running. And then if I do shift and enter one more time, we should now see our data set pulled in. So it's customer ID, date, quantity, and price. Next, I'm going to just real quickly check out the info. I can see some issues here. The date is an int64. I'm going to want to change that to a date time. So that's what I'm going to do right down here. I'm going to first convert it to a string. So this will convert this from a number to a string. And then the next thing I'm going to do is convert to date time. And then I'm going to drop any NA values that are in here as well. So that'll be pretty much the extent of my data wrangling operations, at least for the initial analysis. So now you can see it's a date time. If I run this info again, or actually if I run that down here, CDNOW df.info, we can see that it's now a date time 64. So we should be good, ready to move on. Next section is we're going to be doing our cohort analysis. So we're going to be looking at the customers that have joined within a specific time window. So what we want to do is we want to know when was their first purchases. So that's what this does. We're going to be using a little bit of Pandas. We're going to start with our CDNOW. We're going to sort our values by customer ID and date. So this sorts it by customer ID and date. And then we're going to group by customer ID, shift enter. It creates a group by object. And then we're just going to grab out the first item and we're going to save that as our CDNOW first purchase tibble. Looks something like this, shift enter. And it has now 23,570 rows because there's one observation per customer ID. And it just has their first purchase. So we can see that what the min date was 1997-01-01. And then the max date was 1997-03-25. So this is within that 3-month window. So from January through March 1997. So what we might want to do is next, just take a look at all of the purchases, kind of like at an aggregated look. So what this does is we're taking our CDNOW. I'm going to reset the index, and I'm going to set the index to date. So what this does is just kind of formats with a date over here. And then I'm just going to grab out the price column. So I'm going to grab this, shift enter, got the price. I'm going to resample it by monthly. So this is kind of like grouping by month of purchase, and it creates this resample object. And then I'm going to apply an aggregating function. So any grouping operation, you always have to do some sort of aggregation at the end of it. So we're going to sum up the prices, and then we're just going to plot them. And this gives us a high-level visualization of kind of that purchasing behavior for the customers that are within that cohort. The next thing I might want to do, so now I understand, okay, this purchasing behavior looks kind of like what I'm expecting to see. You know, it starts off real high and then it kind of dies down, and we're going to analyze this period here. And we're going to try and determine which customers were supposed to buy in this range down here, but didn't. And some more customer analytics like that. The next thing I want to know is I want to take a look at a few individual customers, and I want to see what their purchasing behavior looks like so I can see kind of what I'm dealing with. So what I'm going to do is I'm going to take my, I'm going to grab my IDs. So I'm just grabbing the unique IDs that are in our data set. So you can see it's an array, a numeric array here that goes from 1 all the way up to 23,570. And those are the customer numbers, these customer IDs, the unique ones. I'm going to select 10 of them, just the first 10. And you can select any 10 you want or any number that you want. And so I'm grabbing the first 10 out of there. It's an array from 1 to 10. And then what I'm going to do is I'm going to take my CDNOW data set, which is all of my purchasing history, and I'm going to filter it down just to grab certain ones. So I'm going to first grab, the CDNOW customer IDs that are in this IDs selected up here. So only the ones that are 1 through 10. So shift enter, and you can see it cuts down my data quite considerably. Customer ID 1 here has had 1 purchase. Customer ID 2 has had 2 purchases, 3 has had what looks like 6 purchases, and so on. Then what I'm going to do is I'm just going to group by their customer ID and date. So it's going to create this group by object. I'm going to apply some sort of aggregation, again, the sum. So now I have by customer ID and date, I have their the sum of their quantity and the sum of the price on each date. And then this will be, and what I'm going to do is just reset the index. And what this is going to do is give me a data set that I can then visualize. And I'm going to use plot9 to visualize it. So this is what that data set looks like: customer ID, date, quantity, price. It's already in kind of a tidy format, so I can just plot it with plot9. If you're not familiar with plot9, basically it's a port of ggplot. So if you've ever used R, it's a really customizable, it's really easy to customize it and create really professional looking plots. So I'll just kind of step down through this one. The first thing I'm doing is I'm creating a canvas here. And sometimes you'll see this called like a layout. So you're basically picking an x-axis, a y-axis, and then adding a group here because there's a grouping column, which is your customers. So my x-axis is my dates, my y-axis is the price, and my groups are by customer ID. And then you tell it what data set to use. And then I add on a layer. So the next layer is this geom line. So I'm going to add the geom line here. Then what I'm going to add is a geom point. And what this does is add some points so I can see when specifically those customers purchased. And then what I'm going to do is what's called a facet wrap. So what this does is it splits each of the customers out. So I'm faceting by customer ID. So you can see I've got from 1 to 10, and I can actually see their buying patterns now. And then I'm just going to clean up this x-axis so it's not overlapping like that. So that's what I do with the scale x date. I make the breaks every 1 year, and I'm just showing the year with this %y. So that's what I'm doing here. And this is cool because now I can see for specific customers, this customer has only purchased once right at the beginning of our window. This customer has only purchased once. This one's interesting because they have several purchases that they've made. And this is kind of like that repeat customer, the ones that probably have a higher probability of repurchasing in the next 90 days, whereas customers 1 and 2 probably don't. So you can see what's interesting here, customer 4, they look like they've died. So you've got a period here of no purchases, and that's what you don't want to see. You want to try and prevent that. Same thing here with customer number 5. You see a kind of a pretty frequent buying pattern, and then all of a sudden it goes dark. They left. They might have went to a competitor. They might have just lost interest. Who knows? But that's what we want to try and prevent. So that's kind of the buying behavior that we can analyze, and we're going to use machine learning to do that. Okay. So next, what we're going to do is do some machine learning, and we need to frame this problem in a business style of question, so we can hone in and kind of figure out how to format the data in the right way. So the framing of the problem is the most important thing. So when you're learning data science, this is really important to be able to analyze data problems as business problems. So we want to frame the problem in terms of the business. So the first question that we have is, what will the customers spend in the next 90 days? So this is a regression problem because we want to know specifically the amount that they're going to spend in the next 90 days. And then the second question is, what is the probability that a customer is going to make another purchase in the next 90 days? This is actually a classification problem. So anytime we're dealing with probability, it's a binary classification problem. So in order to do this, there's a time element because we're talking about the next 90 days. So we have to do what's called temporal splitting or splitting by time. So that's the first thing that we're going to do. We're going to do in stage 1 here, we're going to have to split this data up by time, and we're going to create a set that we're going to use for developing our target features, and then we're going to use the other data to develop our RFM features. So the number of days that we're going to look at is 90 days. So I'm just going to start saving some of these. And then what I'm going to do is I'm going to look at, okay, what's the max date that's in my data set here? So our max date is just going to be CDNOW date. So the date column, I'm going to grab the max out. And if I hover over this, or if I send this to the console now, we can see that the max date in our data set is 1998-06-30. So what we want to do is we want to then take 90 days from before that last date. So we're going to take the max date and subtract out a time delta of 90. So this is 90 here, and then unit days. So that's what this cutoff is going to be. If I do Shift and Enter, so that cutoff, which is right here, is 1998-04-01. So this is 90 days from the last day here. Okay, so that's what we're going to use as our cutoff, is April 1st, 1998. We're going to then create an in data set and an out data set. So this is temporal in df. And this is going to be all data that is before this date or less than or equal to this date. And then this temporal out is going to be all the data that is greater than that date. So if I look at this temporal out, none of the timestamps, none of the purchase history should be earlier than this date here. And we can see that these are all later, 1998 or later, 04, 01 or later. Okay. So now that we have our in and out, we can then start to create our features from these two different data sets. The feature engineering is the most challenging part. It is kind of a step-by-step process. So we're going to have to first take a look at the out data and create some targets. And these are the things that we're interested in that answer our business question. And then we're going to look at the in data, which is going to be our RFM features. So to create the targets, we're going to take our temporal out, shift enter here. And what we're going to do is I'm dropping off the quantity column. We don't need that. And then I'm going to group by customer ID. I'm going to sum up their purchases. And then I'm also going to, and I'll rename this spend 90 total. So that's the target feature, the spend 90 total. And then I'm also going to assign a flag of 1 to all of these. So these are all customers that have made purchases. And if you notice in here, it goes 3, 9, 25. So this is the next 90 days. So not all customers are present. In fact, only 3,300 of our customers of our total 25,000 or so customers are present. So we're going to save this as targets DF. And this will be the targets that we add in at the end to our RFM features. Next, we'll do our feature engineering, and now it's from the in data. So it's very important. We got out data that we were working with to create our targets. Now we have our in data, which is what we're going to work with in order to be able to assess the features, the descriptive features that we want to relate to the next 90 days, their purchasing behavior. So the first thing we're going to do is we're going to come up with recency, and these are time-based or date features. So basically what we want to know is how recent was their most recent purchase. So we're going to create, we're just going to create a static value called max date, which is the last date that's in our data, our in-sample data set. And this is 1998, 04, 01. And what we're going to do is we're going to calculate by customer when was their most recent purchase compared to this last date. So we're going to get a negative value of dates. So how we do this, we take our temporal in DF, we grab the customer ID, we grab the date, we group by customer, and then we're going to apply a function. And what this is going to do is for each of these groups here, so we've got a group by object, grouping by customer ID. What we're going to do is we're going to take the date within each of these groups, the maximum date. So for the second customer, the maximum date would be 1997-01-12. This third customer, you can see it would pick a date that is either equal to 1997-30, or if they have more purchases, it might be later than that. And then we're going to calculate the difference between the most recent purchase and the max date. So when we run this, and actually this does take a second to run because it's a group-wise calculation. We have a lot of groups in our data set. But what we'll do is you can see we get for each customer ID, how many days, so negative 455. That means that this first customer, their last purchase, their most recent purchase was 455 days from the max date in the data set. So that's basically what this does. It creates our recency features. And when what this does here, so this is a series. I convert it to a data frame, and then I set the axis, which is just going to set the column name to recency. And then our final recency features looks something like this, where it has a name of recency, and it's just basically converted this to a data frame. And the index is the customer ID. That index is important because we're going to blend everything or merge everything together by this customer ID. Next, we're going to make the frequency features. So again, we're working with the in data, and now what we're looking at is how frequently are customers purchasing. So this first customer only has one purchase. The second customer will have two purchases. Third customer will have have more than that, and so on. So we want to convert that into what's called a frequency feature, and it just tallies them up. So how we'll do that? One way to do it is just to take the customer ID and date, which looks like this, and then I group by customer ID, shift enter, creates a group by object. I'm going to apply the count, and what this is going to do is count the number of dates that are by customer, and you can see it's 2003,570 by 1. And you can see like this fifth customer has had 11 purchases, that third customer has 5, second customer has 2, first has 1. And then we're going to set the axis. So this date column, I'm going to basically just set that to frequency. So shift enter, and now I have my frequency features. The next thing that we're going to do is we're going to do the monetary features. So we're again working with the in-sample data set. This time, what we want to do is focus on the price column. So we're going to apply an aggregation. I'm going to group by the customer ID, creates a group by object, and then I'm going to apply or aggregate the price column using the sum and mean functions. So when I do this, if I do shift enter, it creates a multi-index. So you've got price sum, price mean, and then what I do is I don't like working with these multi-indices. So I'm going to set the axis to price sum, price mean, and that's what this does. Just kind of cleans it up, so I don't have to worry about working with a multi-index, price sum, price mean. And now I've got my engineered features. We can use this function called PD concat then to aggregate all of the RFM features. So I've got my recency features, my frequency features, and my price features. I'm going to aggregate by axis 1, hit shift and enter. It just basically creates this data frame here that has all of my engineered features in it. Then what I'm going to do is I'm going to blend in the targets data frame. And this is kind of tricky because initially when I did this, I didn't do it right. I forgot to include how left, which means a left join. So by default, I think it just does an inner join, and it didn't pull over. I actually only had like 3,000 rows because it tried to blend them where both the incoming data and the merging data have the same customer ID, and that didn't work out too well. So just make sure you have how left, and then left index true, right index true, and this is what did it for me. So if I do shift and enter, and I'll show you if I just comment out that and do this, I only get 3,300 rows, and if I look at it, my spend 90 flag is all ones. And I know that shouldn't be correct because there's a lot of customers that aren't making purchases. So the trick is to have this be how left. And then you'll see here too, that there's a lot of NA values that get pulled in because these customers did not make a purchase. So we want that to be a 0. So we're just going to use fill NA 0, and we'll save this as our features data frame. So if I do shift enter, our features data frame looks something like this, where we've got now customer ID is our index, and we've got recency, frequency, and our monetary features, and we're going to be able to relate this to the spend in the next 90 days total, and whether or not they've spent any money, so 1 or a 0. So if they have spent money, you'll have a 1 here. If they haven't, you'll have a 0 here. And if they have spent money, you'll have how much in this column, and we'll be able to analyze their previous buying behaviors to understand their future buying behaviors. Okay. So that's the idea here. Once you get that idea, we're ready to move on to some machine learning now. So we're going to be using XGBoost, XGB classifier and regressors. We're also going to be using the grid search CV. We are not going to be using cross-validation score, so I'll get rid of that. You can run these, but I actually already ran them in the beginning, but it doesn't hurt to rerun them. We're going to make an X and a Y, but because we're making 2 models, our Y is going to be different, but our X is going to be the same for both of these. So our X is going to be our features, recency, frequency, and monetary features. And these are our regressors. And then our Y, so our target variable, is going to be the features DF spend total, shift enter, and it's going to be just a Pandas series. And I'm going to call it Y spend for our first question, which is the next 90-day spend prediction, the regression problem. And what we're trying to figure out is how much are they going to spend in the next 90 days. And we want our algorithm to predict $16 for this person, and we want it to predict 0 for these people. So we're going to create a XGB regressor. So this is our XGB regression spec. We're going to use the XGB regressor function. Objective is going to be regression squared error. And we're going to set the random state to 1, 2, 3 to make it reproducible. And then we're going to use this handy function from Scikit-Learn called grid search CV. We're going to provide it an estimator. We're going to provide it a parameter grid, and this is the search space that it's going to look through. So one of the key parameters to XGBoost is the learning rate. So we're going to change that from 0.01 to 0.1, 0.3, 0.5. So this is going to create 1, 2, 3, 4 different variants of the XGBoost model during our test. And then the scoring, we're going to give it the scoring method of negative mean absolute error. And what this is going to do is going to calculate the mean absolute error, or MAE, and it provides it as a negative value. So meaning we're off, on average off by whatever value that this provides. We're going to tell it refit equal to true. This is important. I think it's actually the default. But so what's going to happen is this refit and the CV kind of go hand in hand. So the CV is our cross validation. We're going to do what's called 5-fold randomized cross validation. So it's going to basically take our data set, split it up into 80% and 20% data. It's going to do that 5 times. And then it's going to create 5 models. And then what it's going to do is at the end of that, it's going to figure out which one of these parameters did the best. And then it's going to fit a 6th model. So that's what this refit equals true means, is it creates a 6th model then, and that's the model that it will predict with when you go into production. So I'm going to hit Shift and Enter. This takes a second to run, or actually no, it doesn't run until we fit it here. So what we did was we basically kind of made a specification to do this grid search now. And what we're going to do is we're going to fit it now to our X data, and these are our target variables. So our X is our feature space, and our Y is the targets. So when I run this, it takes a second because it's got to calculate 4 different models. It's got to do 5-fold cross validation on all of them, and then it's got to train another model. So it's going to take a few seconds to run, but once it's done, we will have and it looks like it's just finished up. We've got now a best model, and that's what we'll evaluate now. So this XGB regression model that we just created, first we're going to check out what was the best score. So this is a negative mean absolute error. So the value, you want a lower magnitude value. So 10 means on average we're off by about $10 per customer. So keep in mind, $10 is actually probably not that bad because some customers are probably spending, hundreds and hundreds of dollars in the next 90 days. So on average, our model is off by about $10 per customer. We can see what the best parameters. So it found that the best parameter was this learning rate of 0.01. We can get the best model. So this is our best estimator, is what it found. And then we can make predictions with that. So I'm going to save this. And what this does is this is how you would predict with it on new data. You just provide the new data in the same format that it was previously trained with. And then we now have our predictions, and it returns what's called a NumPy array. This first prediction, it's predicting that first customer to spend $1.73, $1.78. The third customer, it's predicting to spend $6.56. So that's how you would read this. So our first model is actually done. We just now need to replicate that process for our next question, which is the spend probability. And the difference here is that instead of predicting an amount that they're going to spend, what we're going to do is predict whether or not they're going to spend. So just true or false. And we want to know what the probability is. So the key difference here, we're going to take our feature set and we're going to grab that spend flag, which it's either going to be 0s or 1s. And we're going to save that as yprob. We're then going to create our XGBoost, and instead of regressor, it's now a classifier, and our objective is different now. So before we had regression squared error, now it is binary logistic because it's a binary problem, and we're doing logistic regression. Random state 1, 2, 3. So this is the classification spec for the classifier. We're going to do grid search CV. We're going to, most of this stays the same. The key difference here is our scoring metrics now going to change. Instead of looking at mean absolute error, what we're going to be looking at is AUC, which stands for area under the curve. I'm going to run this again. It will take a second to run, but it's basically doing the same process now for a classification problem. And what it's going to do here, let me fit it. This is the part that takes a little while. The key difference here is our feature set stays the same, but we're now looking at the Y probability, so the zeros and ones. So it should finish up here in a second, and again, we'll be able to go through the best score, best parameters, and so on. All right, looks like it's finished up. We can check out the best score, which was 0.84. Which is actually good. So a 1.0 is a perfect model. 0.5 for AUC is just the equivalent of random guessing. So we're much farther away from random guessing. It's by no means a perfect model, but it's very rare in marketing that you're going to be able to get a perfect model. But the good news is this model does a lot better than just random guessing. We can get the best parameters. So learning rate of 0.1 is the best model. The best estimator is this XGBoost classifier. And then instead of using predict, what we're going to do, because predict will just give zeros or ones, we don't want that. We actually want the probability. So there's a predict_proba function. And what this does, if I hit shift and enter, it's going to predict the probability. So probability of class 0, which is means no purchase, and then which is basically, so this is 0, and this would be 1. So for our binary classification problem, we really just care about this column right here. We can see that this first person has about a 0.02%, or a 2.4% chance of repurchase. This next one has 3%, and then the third customer has a 30%. So that's how you would read this, and that's what we want. We can also, and this is one of the things that my Learning Labs Pro members, the students asked me about, was can you also show how to do feature importance? So we've now made these two models. And one of the things we might want to understand is, okay, which of the features that made these models, which are important? So if we take a look at our X here, these are the features that we want to understand which of them contribute to each of these models' performance. So since we have two different problems, there's two different potential solutions, or two different models that we need to understand the feature importance. So the first one is the spend amount. What we can do is just quickly get what's called the importance. So variable importance, and how we access that is we grab our best estimator, we get the booster, and we get the score from the booster. And this gives us a dictionary of for each of the features and what the relative importance was. So for this first one, that price sum was the most important feature. So let's take a look at this. I'm just going to reformat the data a little bit using some Pandas wrangling, and it puts it into a data frame. And then I can plot that with plot9. So shift enter, and this is what that plot looks like. So I can see for that first spend model, if we think about the question that we're asking, the most important feature to that model is how much they've previously spent, because that dictates how much they're going to spend in the future. So if they spent a lot previously, they're more likely to spend more money in that next 90-day window. Now, remember, that's a regression problem where we're trying to figure out how much are they going to spend. Recency is the next most important. So if they've recently purchased, they're more likely to purchase in the next. But frequency really doesn't matter that much, and their average purchase price really doesn't matter that much. They're really all based off of their price sum, their total purchases previously, and how recently they purchased. Okay, so that's interesting. And then if we take a look at their probability, let's see what's most important. So we do the same type of process here. This time we're just looking at the classifier, and we can see that it's actually different. So before, our recency was our second most important, and frequency was third. Now it's very heavily dominated by recency and frequency. So depending on what your goals are for the business, this has a profound effect. If you want more people to spend more money, you have to focus on the customers that have previously spent a lot of money. And that may make intuitive sense, but that's what this model is saying. Conversely, if you want to retain customers and have their probability in the next 90 days of making another purchase, that's a different type of problem. And you need to focus on increasing the recency of transactions and increasing their frequency of transactions. So these are two different problems. This is actually a problem related to kind of big spenders, and this is actually a problem related to having people not fall off the wagon. So depending on what you're trying to do, these two plots are really important to the business. Okay, now that we've gotten this far, what we're going to do is save our work. So what I'm doing right here is I'm first creating my predictions. All this does, this is a PD concat. And what I'm doing is I'm taking my predictions from my regression model, and I'm going to create a data frame with prediction spend. I'm going to create another data frame with my probability of spend, prediction probability. And then I'm going to create a data frame with my features, and I'm going to combine them all into one data frame called predictions. Predictions DF. So shift enter, and this captures all of the results of our analysis. So we can see whether or not they've actually spent any money, and then we can also see whether or not they were predicted to spend money, and what their likelihood was and how much they were predicted to spend. So this helps us with our application, because now when we make that Dash app, what we're interested in the Dash app is being able to deploy a solution to our company where the marketing people are able to use it and kind of hone in on which customers that they need to focus in on. Whoops, I might not have it running right now. Yeah, I need to rerun my app. So so this is actually refiring up. There it goes. So when they drag this down, these are the customers that they want to focus in on, because there's a big delta between whether or not they've actually spent money versus how much they were predicted to spend. So this customer, for example, customer number 4 was expected to spend $21, and they didn't spend any. So you'd want to target that customer to rebuy. And that's what this application allows us to do. And what you want to do is you want to hone in on the top of this chart, because these ones are the ones that have the biggest deltas and they have the highest probability. And then you can download your segmentation, and this hones in on just those specific customers for your marketing people. Okay, so that's why you want to save this predictions data frame, and then you can save the importance. We do that here, and what that's doing is it's populating our artifacts over here. So our artifacts is just basically the saving our work. So I'm saving here my predictions as a pickle file. I'm saving so if we just do shift enter here, this saves the predictions as a pickle file. If we do shift enter here, it saves our variable importance here, and then and you can read in that data. So this is reading in the importance for the spend amount, which features were the most important. And it's just good to kind of save these artifacts since you put a lot of work into this. And then if you want to save your regression model, we use actually this thing from joblib called dump, and we can save it as a pickle file. And then we can use joblib.load and load in the pickle file. So if we save these, shift enter, and then if we load one of them in and we can predict on it, And you can see if we load this thing in called model and make a prediction, it'll predict for us. So that's how you'll want to save these models and take them into production. And then we can answer the questions. So the final thing is we had these 3 questions that were really important to our business. Which the first one was, which customers have the highest spend probability in the next 90 days? We can answer that here. And we can see here that very quickly, if we just sort by our prediction probability, these ones are the highest probability to purchase. And we can even see whether or not they purchased. So for example, this first one had a really high probability and they actually spent $285. This next one had a high prediction probability, 97%. They were predicted to spend $1,000 and they actually spent $2,500. Third one, $1,000, they actually spent $1,700 and so on. And you can see kind of how the model's working. So pretty cool. The next thing is which customers have recently purchased but are unlikely to buy. And the goals here are we want to incentivize actions. So this kind of relates to that recency. We want to get them to keep buying. So we want to incentivize actions to increase their probability. We want to maybe provide discounts, encourage referring friends, nurture them by letting them know it's coming, maybe give them deals for smaller items to get them buying and to keep reviving them and revitalizing. So you can see here, these people have purchased here relatively recently within 90 days, but they have a prediction probability that are in the lower range, so 19% or so. And then the missed opportunities. So these are the big spenders that we have. Our model believes that they should be buying. Like for example, this person here, customer ID 21685, was predicted to spend $153, but they didn't spend any money. So these are the people that we really want to focus in on, because this population represents a lot of money that's sitting on the sidelines that we could potentially generate revenue from these people just by sending them a well-timed email that kind of reinvigorates their spending. So that's the power of this stuff. If you like that, how can you learn more? Well, we've done a lot of powerful stuff just in this learning lab, but we're also talking about some of the concepts that are really not necessarily unique to this particular problem, but unique to almost every data science problem. So if you think about what went into this analysis and what you need to learn in order to be able to do this type of thing for your company, what you can focus on, there's key concepts. So things like data wrangling, modeling, and visualization, these are what I call foundational skill sets. And I'll talk about this here in a minute, but those are things that I teach in my 101 course. Which is I'll talk about here in a few minutes. If you're interested in learning how to improve the models, so we just made 2 different models, and we did the grid search CV. But there's other algorithms. There's also this thing called AutoML, and there's also more extensive hyperparameter tuning and knowing which parameters to tune and how to tune them to get good models. These are the things that I have coming in the next course. It's called 201-P. I'm going to be coming out with that in a few months, and I'll talk about that more in a second. There's also this concept of forecasting. So what if your business question changes slightly and says, okay, not who's going to purchase in the next 90 days, but when are they specifically going to purchase within the next 90 days? And that is something that forecasting can help you out with. So I don't have a course quite yet in Python. I do have one in R. It's called my High Performance Time Series course. It's really good. And then we have web applications, APIs, and productions. That's coming in 202P. Again, I'll talk more about that here in a few minutes. For the people who are joining Learning Labs Pro, if you want this application, and I'll put the app here into the Learning Labs Pro link again into the chat. So I've just added it into the chat. Take a look at that real quick. The app, how you'll get this to work, you have this app.py file. You just basically run these commands in this text file. you're going to do your conda activate. So I have a terminal open right here, and you're going to run conda activate and make sure that this is activated. So when you do this conda activate lab 59 customer lifetime pi, it's going to activate this environment for you. And then all you're going to do is run python app.py in your terminal, and it's going to start running this on your server. You'll navigate to port 8050. So just type in localhost 8050, and that'll pull the app right up for you. Okay. And there you have your Dash app. Okay, that's pretty much it for the tutorial. For those that are still with us, I do want to talk quickly about the business science programming and give you guys some ideas of what's coming soon here in the Python track. So I want to talk a little bit about business science. So business science has largely been an R training company. And I founded business science because I have honestly been using R for 10 plus years, and it's been amazing for my career. It's given me so many opportunities, and it's really helped me succeed and propel my career and get promotions and do the things that I wanted to do with my companies that I was working for. But recently, we've now expanded into Python for a reason. And I want to talk just a little bit about that reason. So, these tools and techniques that you're learning are very important to your career. But now I want to show you kind of some of the changes that are going on out there and talk about what I'm seeing and some of the amazing things that are happening. So if we think about data science, largely it's been R versus Python, or a lot of people feel like they need to pick one or the other. And then that kind of choice, they feel like it that's the only thing that they can ever do. But there's a lot of changes that are happening. And I trust me, I picked R when I was first starting out, couldn't be happier. But now I'm at the point in my career where I'm also learning Python, and here's why. So what I'm seeing is that when there's some new technologies that are advancing that allow us to connect both R and Python up, and this allows us to get results. So this was before R versus Python. Now what I'm seeing is R and Python working together. So here's a specific example of what I'm talking about. Back in November of last year, I've developed in R the system called Model Time for forecasting. It's really powerful. It's amazing. And what I was doing at that point in time was a lot of research into all the different tools and techniques that are out there to do forecasting. And one of the tools and techniques that was winning a lot of competitions was deep learning. Now, R traditionally doesn't have a whole lot of deep learning in its ecosystem, but a different ecosystem, a different language, Python, has a lot of deep learning capabilities. So initially, when I figured this out, I was like, man, this is a kind of a bummer. I was actually a little upset because I saw this library called Gluon TS, which is really good for applying deep learning to time series, but it was only available in Python. And I thought to myself, I'm like, I can't use it. And this isn't going to be good for model time. So I started doing a lot of research. And in fact, there was a lot of other people that were having the same type of issues. And fortunately, there was a solution that came out recently in R called Reticulate that allows us to bring Python into R. And then I started doing even more research. And there's also a similar type of solution in Python that allows Python to bring R over. It's called RPy2. So what it allowed me to do was create this package called Model Time Gluon TS, which leverages in the comfort of R, being able to do the ease of model time to do forecasting with the power of Gluon TS and Python. And I was able to combine those two through Reticulate to develop an R package. And this was shocking to me. It showed me kind of the power of combining these two languages and what the possibilities are of the future, not only for me, but then I started thinking about data science teams. So I started thinking about and talking with businesses where they have, these different people that are all part of their collective data science team. And some of them know R, some of them know Python. Some of them are kind of better in certain aspects, like maybe machine learning operations, or maybe they're more research analysts, or maybe they're big data people. But the idea here is that, you've got Python and R, and they're good in certain things, but you also have people, and people naturally tend to go towards, different things. Like for me, research was always really important. So that's one of the reasons I chose R, was because it's so good for research. It's got so much, so much in terms of, R Markdown for reporting. It's got all of the tidy model suite now. It's got the tidyverse for data wrangling. It's just really good for doing a research, quick ad hoc research. But you also have people who choose Python too, and they're choosing it for different reasons, because they like maybe the aspect of all the APIs and the web-based stuff that you can do with Python. But the idea here is that teams get result. You don't want to have all the same people. You want to have players, and that each have different roles and different skills. And these tools that are out there can be better suited for different positions. So the key here is now we have these different technologies that allow us to integrate rather than try and feel like you're forced into one language or the other. Now we can have teams that actually know R, that know Python, and we can integrate solutions and deploy solutions that use both. And it doesn't even matter. It doesn't matter what you know. It just matters that you can integrate. So this is an amazing thing. And then it's what led me to kind of the roadmap for business science. So what I am working on right now, over the past 3 years, I've developed this R track, and it's 5 courses. It starts with a foundational course. It also has the web apps that are done in Shiny. And it also has the machine learning, which has the AutoML, explainable machine learning, and then my high performance forecasting, which is my model time package, TimeTK and Gluon TS. And as you can see, these R track courses are completed. And now what I'm working on, and I've just launched here recently, is the Python course. And I'm working on this Python track specifically designed for people who want to learn machine learning for business and automations. So I've just released Python for data science automation. And what this teaches is, you saw in this lab here, VSCode. Teaches VSCode, teaches Pandas, teaches Plot9 for plotting. It also gives an introduction to SK-Time, and it teaches probably a half dozen or a dozen other technologies and how to integrate them all, and actually build Python modules and Python packages. So that course is done, and where I'm headed with this track is now to start into the machine learning component, which is, we saw a little bit of that today with Scikit-Learn. So in this course, we're going to be learning pipelines, how to do machine learning with Scikit-Learn. And then we're going to learn some of the newer technologies for automated machine learning. I haven't decided yet exactly which technologies I'm going to be focusing on, but I think either PyCaret or H2O and Dask as I formulate the lesson plan and the curriculum for this course. And then eventually what we're going to do is model deployment. We're going to be talking about doing Dash apps. We're going to be talking about doing APIs. And then eventually we're going to have a course that shows you how to integrate both Python and R, no matter where you're coming from. So if you know Python, but you want to integrate R, you're going to learn RPy2. If you conversely, you know R and you want to integrate Python, you're going to learn Reticulate, and you're going to see examples of how you can do this and blend these technologies together so you can work cross-functionally in a team. So that is kind of the idea here. I'm going to put some links into the chat. The first link I'm going to put into the chat is the Python for data science, because I think that's probably most applicable to you guys. Is the most recent course is the Python course. And what this is designed for beginners who want to learn how to do data science automations with Python. It's designed to be able to take Excel files, which are commonly, asked to work with, and put those. You'll start by putting them into a database, and then you'll create through this automation process. You'll learn Pandas to help you create these functions here to summarize by time, to collect data. You learn SK-time to do ARIMA forecasting and plotting. You learn how to work with databases to update a forecast table using a write and read function that you create. And then you learn how to automate reporting through for this forecasting project. And you learn how to do a ton of stuff through these types of projects. So this is just the first course in that system. So if we go back here to the system that I was talking about, that's this course right here. And for the Python folks that want to learn Python, it's going to be the foundational course that then takes you to the next course, which is where we're going to learn a lot more machine learning. So this is a really good course. Definitely check it out. I'm giving you guys 15% off today for joining us on LL Pro, and you can sign up. For the R people who are just now first learning to dabble into Python, for those that want to learn R, I have another, I have the full 5-course R track. I'm also going to give you all 15% off if you're interested in that. It's a really powerful set of tools. It'll take you probably, several months, probably like 9 months to complete because there's 5 different courses, but it takes you from the foundations, learning how to do the data wrangling, learning how to do the visualization, the business reporting and the machine learning, to then how to work within companies, leveraging, actual data science frameworks and automated tools like H2O and Lime for explainable machine learning. It teaches you time series using my model time package, TimeTK, Gluon TS, how to work with time series, and then how to build and deploy Shiny web applications. So learn Shiny, HTML, AWS, Bootstrap, MongoDB, Docker, Git. You learn all of this through a progressive system. And the beauty of it is it helps you keep making progress. So while it progressively increases in difficulty, that difficulty, the rate at which it increases in difficulty stays constant. So you end up learning a lot. And by the end of it, you become an expert. Okay. So the ecosystem is large. How can we cover everything? So this is a question that I commonly get. So that's why Learning Labs exists. So you're watching Learning Labs today. I'm also going to give you guys the Learning Labs code again. Feel free to join Learning Labs. What Learning Labs is designed for is 1-hour mini courses that are outside of the scope of the core curriculum. So this is for people who already kind of know the foundations already. It's very powerful concepts and tools, and I give away a lot of awesome bonuses, but it's not for the pure beginners. So if you're a pure beginner, I would definitely point you to the either Python track or the R track, depending on what you're looking for. But for those that already know, have a little bit of experience, Learning Labs can be a nice complement to help keep you pushing. Okay, so that is the systems, and I hope to see some of you all in there. Now what I'm going to do is hang out for a little bit and answer some Q&A. So if you have any questions, put them in the chat. I'm going to open up the Q&A right now, and I'm just going to go down through one-on-one. Okay. Do you have labs specific to Python? So this is from Sandeep. I do have labs specific to Python. This is one of them. This is the first one actually that is pure Python. I've done other labs in the past where we've played around with Reticulate and some of these other things, but this is the first one that's pure Python. Can you please send the link to the previous labs? This is what Anthony asks. It's in the chat right now. So just click the link and you can get access to it. Hi, Matt. I just bought the 3-course bundle plus 1 Shiny course plus Learning Labs Pro. Question: how should I weave the Learning Labs while go through the 3 R courses and the Shiny course? For example, do you have whole Learning Labs on tiny models? So this is a great question. And one of the things that happens is, like, for example, when you go through the courses, you learn tidy models. And I teach you the foundations of tidy models in the courses. Like, what are all the algorithms? How do they work? What are the key parameters? But in the Learning Labs, you can imagine this tidy models is an ecosystem in R. It's kind of like Scikit-Learn in Python, but it keeps growing and they keep adding more and more packages. So the newer stuff like text recipes, like the embed library, like some of the workflow sets. We've got now labs on those that are in addition, that kind of are, extend what you learn in the core courses, so you can build on your knowledge and learn the most recent technologies that keep coming out. So what I would recommend is take the courses, learn the foundations first, and then once you get that first 101 course done, that's when Learning Labs becomes really special, because you can then start adding in the additional information that I've added in the labs, and it'll make sense to you. If you do it too early, it won't make any sense, and then it'll hurt your confidence. But if you do it after the 101 course, then you'll be ready to go. Les asks, sorry, I missed the first part of this. Will I be able to see a recording? In Learning Labs Pro, if you join LL Pro, I will have the recording up tomorrow morning. So it usually takes me a couple of hours tonight to get things cleaned up. Carlos asked, what was your criterion to choose the XGBoost as opposed to random forest? Well, I didn't really pick XGBoost. Almost always does pretty well. There's only a few certain situations where you definitely don't want to use XGBoost. Some of those are like time series, when you only have one time series that you're investigating and you have a trend component. But that's neither here nor there. For this particular problem, I chose XGBoost because I felt like it would give me a good result. But here's the thing. This is just a learning lab. I don't have time to go through 50 different models. But when you get out there into the real world, you want to test these models, and you want to even build things called ensembles, which help you leverage kind of the benefits of multiple models. That's what things like H2O do, AutoML, and that's what things like PyCaret do, and some of these other ones. So I definitely recommend trying multiple different machine learning algorithms and not falling in love with one. And don't feel like I'm falling in love with XGBoost, because in my internally into my business, I don't just use XGBoost all the time. I actually use H2O, and I often use stacked ensembles, which does a stacking approach to ensembling. So good question. Don't fall in love with one algorithm. If I had to sum it up. All right, next question. Dirashan, have you tried to implement a Pareto NBD model? Yes, I have, and that's what I was referring to with the Econometric. I've tried it. I actually tried it for Last Lab because there's lifetimes in Python. That's a Python package, and then there's also another one in R. It's like customer. I can't remember what the name of the package is, but I used that package in R last week. It didn't give me very good results though, so I switched up and I started looking at the machine learning approach, and that's the one that I prefer, because I implement it and it actually gives me really good, useful information that's quite accurate versus the Pareto NBD model. So good question. And have you tried implementing a DNN for the CLV calculation? I don't know. Is that a deep learning neural network? I don't know what the, I'm sorry, you'll have to forgive me, Dirashan. I don't have I don't know what the DNN stands for. Interested, Dirashan also asks, interested to know if development time yields a significant enough improvement to a simpler model. Good question. What I would definitely recommend you try is experiment. You won't know for sure unless you try it out. So always try your questions out, and then you'll know for sure whether or not it works or not. Ryan asks, can you explain multiple learning rates again when you get to the end? So yeah, this is a good question. So the multiple learning rates is basically what we're doing here is we're cycling through and building models out with each of the different learning rates. So we're going to build a model here with 0.01, and we're going to train and test it 5 different times using cross-validation. And then we're going to do the same thing here. We're going to set the learning rate to 0.1, and we're going to create 5 different models on training and testing sets. and then calculate what the average AUC is for that particular model. And then the next one we're going to try was 0.3. So we're just basically cycling through, and that's why it took a little bit to train, is because those models have to be produced and we have to assess them on training and test set five different times for cross-validation. So that's what we're doing there. Carlos asks, why is Y spend included in the fitting process? Well, that's our target. So what we're trying to do here with Y spend, which is right here. So this is our it's our spend 90 total. It's basically the column here. We're trying to predict what our next 90-day spend will be using the X values, which is our recency, frequency, and monetary columns. Okay. All right, Paul asks, is there already a blog post about how to set up Python development environment with VS Code, etc.? I haven't put the blog post yet. I'm going to try and do it for tomorrow. I'm definitely going to need to include some instructions because, it can be a little tricky. And from the 101 course, I already know there's a ton of challenges because everyone has different operating systems like Mac or Windows, and they all have different issues that they run into, like adding path to the adding their conda path, the path to the conda in their Windows environment, and making sure that they have C++ installed and those sorts of things. So I will put something together. So hang tight. I promise I will do it. Elizabeth asks, does Scikit-Learn show which feature had the most impact on the prediction? So it's not Scikit-Learn, it's actually XGBoost. The XGBoost model has the feature importance, and we extract it out using grabbing the best estimator, get the booster, and then get the score. So that's what this does. This gives us our feature importance. Now, this is a global feature importance, so it doesn't tell us specifically, why customer one is either likely or not likely to buy. But what it does is it says on average, the price sum tends to be a pretty important feature to the future spending amount. So you should try and, increase that or target those customers if they're not spending in the future. Jerome asks, can you quickly discuss thoughts on building tools in Shiny versus Dash and machine learning in R versus Python? Well, it's not really probably a quick discussion, but I will say at a high level, Shiny and Dash are very similar. Shiny does have a very robust ecosystem in R. I'm more comfortable with the Shiny, but Dash is also very good. And I was able to build an app. I just started it this morning, and within a couple hours, I had that app built. I thought it turned out pretty good. Machine learning in R versus Python. Python's actually a little more developed on the machine learning end, but R is getting the tidy models ecosystem, which is what I teach in my courses. And it's also very good. I really like R. I use R. I've been using it for 10 years, and it just keeps growing and getting better. And it's really good for research. I will say that if you have to make a lot of reports, in my opinion, I think the main differentiator between R and Python that people don't necessarily look at the most is just the ability to make reports. R is a statistical language designed for reporting. Jupyter isn't really designed for reporting, in my opinion. It's very tough to make a good looking PDF report. But Python is very good on the machine learning end. And if you're really interested in that, we saw Scikit-Learn in here. It's pretty good. It's pretty easy to get up and running. Can you please share the notebook and the dataset? I will share it. It's in Learning Labs Pro. It is a paid membership, but if you join, you will get it along with the 58 other labs that I have in there. Ricardo asks, hi, Matt, what other hyperparameters would you add to the parameter grid to achieve better scoring or avoid overfitting? So what I commonly will do is I usually start off with just the learning rate. So I usually actually do XGBoost in 2 steps. And I think I teach this in my time series course. It's kind of a trick. I do a first stage where I just focus on the learning rate. I find a good learning rate. And what that does is it helps me to because the learning rate's the most important. If you get that wrong, then it doesn't matter what other parameters you have. You're not really going to get much improvement. It's going to be a pretty crappy model. So get the learning rate first, and then hold that learning rate constant, and then vary the other parameters. So things like the number of trees, the difference. Basically, there's a bunch of different hyperparameters. Then you can kind of fine tune them, and that's what I would do in a second stage. Neha asks, "Hi there, thanks for the presentation. Can I get the recording?" Learning Labs Pro. Anonymous asks, "This is a kind of basic prediction for spend. In the real world, you look at categories of product spend by the customer. Do you have other data that has similar workflow that contains categories that customers purchase?" I do. And that's called business sciences data. So we have products and so on. Now I do in my courses, the next course that I'm coming out with, the 201P, where we do the machine learning, we're going to be using our actual data that's been anonymized and sampled down. So you don't know, it doesn't have any emails or anything in there, but you'll just have like customer IDs and so on. But we'll have actual product categories and those sorts of things. So it's a cool data set, and I will be, it's something to look forward to in the 201. Anonymous, "Hi, Matt. Great and very informative. Would you advise adding more features such as demographic?" Yes, so that's a great point about this RFM analysis. The nice thing that we're doing here is that we can get, if we have like gender, for example, or geographic information about the customers, because actually in the data that I work with, I actually have the geographic information for a lot of my customers. And I know where they're purchasing from and so on. So the beauty of this is that you can add them in, and there's just more columns. So instead of just doing a recency, frequency, price sum, and price mean, what we can do is we can add in, the geographic feature where this customer is located, if you know that, what that gender of that customer is, and so on. And you can really get pretty powerful models. So what I do is we have a lot more features in addition to these types of features. Next one, Chandra Kanth asks, "Hey, Matt, you have performed train test split in order to train the data and use the same data to train and predict. Can you talk a little about it?" So yes. So what ends up happening inside of this cross-validation is we get the training, we get the testing error. And what ends up happening is you get a best score. And this score is the best model in the average of 5 of the 5 models that produce. So on average, you're getting 0.838 AUC. And then what I do is it creates a 6th model, and that's what we're predicting on the full data set then. And what this does is it gives me all of my probabilities. So that way I know which customers, and I can hone in on specifically which customers that I need to. I know it's going to be the most powerful model. So that's kind of how it works. Basically, we're using a machine learning model to help assign probabilities to everybody, all of our customers. And then we're going to provide that data to marketing via an application that looks like this. And it's going to allow them then to basically see the information that we have and download the segmentation so they can start creating their email marketing and targeting those segments. Okay. Lucas asks, "Hi, Matt. Sorry I joined late. What is the time period for frequency, and how is it aggregated to be used as a predictor for purchase probability?" So the time period for frequency is going to be all the training data. So when we did our temporal split here, so our temporal split looked something like this, where we split it up into we created our target features from this, and we created our RFM features from this blue piece. So it's whatever this is from January 97 all the way through March 98. It's basically tallying up for every customer how many purchases, and that's what we're calling frequency. So that's how that was aggregated. It's just the sum or the count of how many purchases they've made for as a predictor. So good question. Anonymous asks, "Could you please type the names of the 2 libraries that allow combining Python and R?" I'll put it into the chat. It's RPy2 is the first one, and the second one is Reticulate, and that's for Python, bring Python into R. Krishna asks, "Will you be sharing the deck?" Learning Labs Pro, I will provide the deck. Jefferson asks, awesome presentation as always, man. I'm not too fond of Dash. Is it possible to incorporate the Python machine learning code and run? Yes, absolutely. And that's another thing that I was thinking about was I myself am a little bit more proficient with Shiny. So you can easily incorporate your Python environment. So the Conda environment that we created, we can set that up. And then we can set up the machine learning models and all to run through Shiny as well through using Reticulate. So it's pretty powerful. Sandeep asks, is in the learning labs, can the projects? Sorry, Sandeep, I'm not 100% sure what you're asking there. You will get projects. These projects are all in learning labs. Kieran asks, thank you, Matt. Planning to take the Python track. Does LL Pro come with it, or do I need to purchase it separately? So unfortunately, we do have to offer LL Pro separate. It's an add-on. And the reason we do that is because I'm always adding new content to the LL Pro, whereas when you purchase the courses, you get those for life. So there's a little bit of a different kind of business model for each of those courses. And as new courses get added to the Python track, will that need to be purchased separately too? Yes, but we offer upgrades. So basically, you're always getting the best possible offer because you'll when you upgrade. And my wife handles all of this. She will work with you in order to get you into the new courses, and it's pretty seamless. So there is no disadvantage to starting the courses now. In fact, it's quite the opposite. Start the courses now so you're ready for the next course when it's released. You'll have the prerequisites taken care of. So good question, Karen. Eric asks, any additional resources you've used in the past have turned academic understanding of this whole process into the practical? So I used to do this all the time. I used to look at all these different papers. In fact, when I started learning R, it was quite a challenge because all of the different most of the different like cutting edge techniques weren't being implemented in business. Rather, they were being implemented in, some sort of like case study on like weather or fish or something like that, biological. And I think that was just a function of who was using R at the time. And now it's grown and grown and grown. So there's actually a lot more like in the marketing domain. I encourage you to just check out books online, honestly, and then research specific projects. And then also, obviously, if you're interested, the business science courses, I mean, it will accelerate you as well. The idea here is, I put in all the time, 10 plus years, and I kind of bottle it down into the trainings and the courses that help you learn in, just a few months. Karthik asks, what will be the next use case for the Python R lab? So right now, I think we're looking at marketing mix modeling. But what I want to do is I want to actually ask the Learning Labs Pro members and see what they're interested in having next. I'd like to keep it in the customer analytics realm. Karthik asks, why have we not done train test split, taken all the data features? It's because we did the cross-validation. So we just did the CV. We did a 5-fold cross-validation using the grid search. Bilgi asks, will you share the presentation after? Yes. And just sign up for LL Pro and you'll get the presentation, you'll get the video, you'll get the code, everything that I've shown here today, you get. And then the last question, I'm probably going to butcher this name, Ichtayad. Thank you, Matt. How can you use Python for item response theory? I'm a PhD, assessment and evaluation. I'm not 100% sure what your use case is, but I'm sure if you follow the scenario in the learning lab and in the courses, you'll probably be able to apply it to your specific problems. I'm a fan of learning the concepts, which tools specifically and how they integrate. And once you go through that repetitive process of learning how to apply data science to business, you generally can then take what you learn and apply it to any problem. So your assessment and evaluation problem, you're more than likely going to have the tool set and the skills to actually be able to apply it to your problems as well. All right, that's it for questions. I want to thank everyone again for attending. This was a great learning lab. I hope you enjoyed it. And in 2 weeks, we'll have another learning lab. So I will catch you then. Until then, thank you so much for attending, and I'll see you later. Bye-bye.